So welcome everyone to the Food for Thought speaker series with the EMPA Picker Center. We're honored to have our wonderful guest, Eduardo Escobar, with us to discuss Babylonian modes of thought and the scientific imagination. As always, please keep yourself on mute unless you're asking a question, and you could always put questions in the chat. Our sessions are every Wednesday from 12 to 1, and you can find our sessions recordings, past sessions, and future sessions on the Food for Thought website, which we put in the chat. So thank you everyone for joining us for our weekly session, and I'll hand it off to Bill to do the introduction.
Thank you, Jeremy, and thanks again, as I always say, to Jeremy and Valerie for keeping this wonderful session. And Monica has now joined us as one of our regulars, and of course Adela Gondek, Professor Gondek, who's our most reliable attendee. But not to diminish anyone else, we love you all, every one of you, and all of us are important. And it's great to really come together and expand our minds every Wednesday. So we're coming back from the winter break. The groundhog saw his shadow, which means 6 more weeks of winter. But, you know, the sun generally dictates, and there are always 6 more weeks of winter. Sometimes it's warmer than other times. So that's the good news. We're just under 7 weeks here in our area of winter, thank God. So we're looking forward to that. And we start with one of the most fascinating and innovative presentations we've had in our now 3rd year, as we begin our 3rd year. So Professor Escobar is a PhD from Berkeley, where my wife got 2 of her degrees, and just like us, he has a degree from Columbia, and also from Cooper Union. So he's from our neck of the woods, but he's a long way away from home. He's at the University of Bologna in Italy. And he, even at a very young age, has not only won numerous awards and numerous achievements, but he's one of the world's experts on science of the ancients. That's not really what it is, but that's what I call it. And his talk today is about a civilization that you probably all read about a little bit in elementary school or high school, or maybe a little bit as an undergraduate. But Babylonia was one of the great cities of the ancient times. I think that's where Alexander the Great died, if I'm not mistaken. And so I've watched all sorts of cheap movies, B-class movies, and terrible TV shows about all this era. I've always been fascinated about it, but today we'll actually hear from someone who has mastered 7 languages, by the way, who actually reads the original versions of these stories and reports. And I think you'll be blown away by what he has to tell us today, in particular, the connection of what went on back then to people who we know from the 20th and soon 21st century. So same rules as always. We will stop without respect at 1 p.m. no matter what. And from this moment on, Professor, you are in charge. So as you can see, he has a very detailed PowerPoint. We look forward to hearing it. Hopefully we'll have some questions, but if we don't have time, as you can see, his email is on the slides, and we also have his connection. So feel free to raise questions or issues after today's session, and we'll find him. We know where he is, and I know his family, so I can track him down. So Professor, again, thank you so much for joining us. And I'm going to mute myself and turn it over to you.
Thank you so much. First, let me thank the School of International and Public Affairs at Columbia University, particularly Professor William Imeke and Valerie Zimmer. Thank you for organizing this lecture and hosting me from afar. This Food for Lecture series provides me an opportunity to share with you that favorite pastime of historians, which is, of course, the past, its near and distant echoes, and the continued existence of the ancient world and ancient concepts in the present. And with that in mind, I begin this lecture with a claim. And that is this: whether we know it or not, we are all in some way Babylonians. To take just one example, this 1-hour talk is based on a Babylonian arithmetic principle, a division of units according to a base 60. It's what we call the sexagesimal system. This method of counting, which may seem natural and even objective to us, is very much cultural and Babylonian, to be more precise. Before Pythagoras, the base 60 was used to calculate Pythagorean triples, those 3, 4, 5 triangles you remember from geometry in middle school. Here on display is a near 4,000-year-old tablet housed at Columbia University, just in your backyard, demonstrating the sophistication of Babylonian mathematics during the early 2nd millennium BCE. This same base 60 was used by Babylonians and is used today, actually, to map the night sky, and was then used to prognosticate the future. That mathematics is cultural and that it structures our mental images is something we come to know from the history of science as well. But also from the Babylonians, we take concepts of language, cosmology, mythology, death, and uncertainty, a topic which we will deal with today. But today's talk isn't just a list of Babylonian contributions to the present. Rather, I want to share with you something of more recent history, a Babylonian mode of thought, and the way that Babylonian mode of thought entered the 20th century scientific imagination. My talk today begins with an archival journey, a search to discover the origins of a curious quote uttered by the famed economist John Maynard Keynes during the tricentenary of Newton's birth. Isaac Newton, of course, is the Newton I'm talking about. The quote reads as follows: "Newton was not the first of the age of reason. He was the last of the magicians, the last of the Babylonians and the Sumerians." The quote struck me as important for two reasons. First, it established Newton as a descendant of an ancient method of scientific inquiry, a descendant of the Babylonians rather than the first scientist of the modern age, as he is typically depicted. Second, I was compelled to find out why this famed economist knew anything about Sumerians at all, which strikes me as strange given the year. As I came to find, the story of how this comparison between Isaac Newton and the Babylonians and Sumerians came to be is a story that includes a search for the origins of money and a love affair with an abandoned Russian ballerina. Here we begin with the first part, his search for the origins of money. In the mid-1920s, he began to discover that coinage and the origins of coinage did not originate in the ancient Babylonian world. He tried to reconcile, John Maynard Keynes, in writing a history of money, where money came from, the concept of money, how long-standing it was, and where it could find its origins. In these unpublished notes that I found at King's College at Cambridge, we find here that he was trying to reconcile different weight measures and standards of money that dated back to the 3rd millennium BC. In correspondence with other Assyriological professors at Cambridge and Oxford University, he tried to establish correspondences between one mina or manna of a standard weight that belonged to the king of Babylon, Nebuchadnezzar, and that could find its origins 2,000 years earlier in the 3rd millennium. Pardon, there's a bit of a delay. In this quest, he found that he could not reconcile the very obvious thing that we would know now as historians, weights and measures that were separated by centuries and millennia. And so this project failed. This search for the origins of money in Babylonia remained unpublished, and it remained in notes for over 4 years of research. What he did find, however, was something curious. He found that coinage was not as important as he once believed. The metals, he said, that had been used for money for very many centuries before was mostly a convenience and perhaps partly advertisement. He claimed that the Babylonians had coinage or managed without coinage for thousands of years and had great economic or long-standing economic systems. After years of research into Babylonian and Sumerian coinage, he found that he was actually capable of becoming an expert, or was expert enough in the field to actually review books that were coming out during his period on the history of Assyria. Consider for a second a modern economist like Keynes, or of his level, if such exists right now, writing about the latest publication of cuneiform tablets. It was certainly a different time. Pardon again the delay. A deeper search into the Cambridge archives revealed another part of this story, his interest in the Sumerians. And this part includes a set of correspondences and letters between himself and a Russian ballerina. Between 1924 and 1925, the documents at Cambridge show that these love letters spanned a number of years, beginning in 1922, when Lydia Lopakova was 30 years old and Keynes was just 39. It was at this time of Lydia's career with the Diaghilev's Ballet Russes that she was abandoned. A production of ballet ended abruptly, and Diaghilev left his dancers stranded in London during this period. Keynes arranged for the young ballerina to live in the same building as Vanessa Bell, Virginia Woolf's sister, in 50 Gordon Square in Bloomsbury. Keynes himself commuted between Cambridge, where he was deeply involved in university life, and for years, he would go back 2 times a week to London, where he and Lydia would, when they were apart, write love letters. At the time, the British mail system was so good that Lydia in London could post a letter in the morning and have it reach Maynard in Cambridge by that afternoon. Here is one such letter. My dearest L, I feel better than a lunatic this evening. It is just like 3 years ago. The same thing has happened. Feeling rather leisurely, I return to my old essay on Babylonian and Greek weights. It is purely absurd and quite useless. But just as before, I became absorbed in it to the point of frenzy. Last night, I went on working at it up till 2 o'clock. And today, I went on continuously from the time I got up until dinner time. Extraordinary. Anyone else would think the subject very dull. Some charm must have been cast on me by a Babylonian magician. The result, I feel, is quite mad and silly. Lydia responds, I am in full sympathy with your Babylonian madness. Apologize for that delay. I think there's an internet lag here. He responds, my dearest L, I found this love poem in my Babylonian researches, written by a woman more than 2,000 years before Christ. It is the earliest we know. And here is the Sumerian part of why he compared Newton and to the Sumerians in Babylonia. Come to me, my Ishtavar, and show me your virile strength. Push out your member and touch with it my little place. From intellect to the Babylonian poem, what openness of mind. I smiled from head to foot, she said. When I tell you of thrillings, she said, touch with it my little place. A pristine woman, no doubt she was. I want to hear and to listen more to Babylonia. Except this poem, I remember nothing from history but the Babylonian smashing, surely here referring to the fall of the Tower of Babel. My dearest poopsick, he continues. This morning I had nothing to do, so I took out the basket where my book lies and admired its takes of contents. Then I read the first chapter. This needs a response to my manuscript on ancient currencies. But when once that was taken out, I was a lost man and spent the rest of my mornings trying to remember my theories about Greek and Babylonian affairs. I feel drawn to waste a little more time on these things. He continues to say here, as he's working on reconciling Greek and Babylonian weights, term draws to an end, and my work has grown less. So I have very little to do except study Assyriology and Babylonian matters. This I do hour after hour with pleasant dry winter outside, very peacefully, except that I am angry when anyone comes in to interrupt me. Here then, we come to the close of the second chapter. That is an explanation of why Newton and the Babylonians and Sumerians were of interest to John Maynard Keynes in that quote, which we'll examine shortly. But a last piece is missing here. Why his interest in Isaac Newton? And here we come to his, to the history of John Maynard Keynes as a bibliophile. Early on during this period, he became interested in collecting the manuscripts of Isaac Newton's estate. And here we find a letter written to one of the publishers. In 1936, a Sotheby's sale allowed John Maynard Keynes to buy hundreds of manuscripts.
Congressman Blumenauer may have joined us.
Hundreds of manuscripts that were in possession of Isaac Newton's estate, which contained his alchemical papers and were then not known beyond the family. John Maynard Keynes, in fact, was one of the figures that brought to light knowledge of Newton's alchemy. During that same period, he was able to be in contact with the Society of Alchemy and Early Chemistry, which asked John Maynard Keynes to speak at the same time that they were asking Assyriologists to speak on the very earliest, let's say, alchemical recipes or glass-making recipes dated to the 7th century BC. And so this was very much at the brink of when all this knowledge was very much brand new within London. Now we can look at the full quote in context. This was a speech that John Maynard Keynes delivered after all of his research on Babylonian and Sumerian materials. The speech, entitled Newton the Man, celebrating the tricentenary of Newton's birth, said the following: in the 18th century and since, Newton came to be thought of as the first and greatest of the modern age of scientists, a rationalist, one who taught us to think on the lines of cold and untinctured reason. I do not see him in this light, he said. I do not think that any one of those who pored over the contents of that box which he packed up when he finally left Cambridge in 1696, and which, though partly dispersed, have come down to us, can see him like that. Newton, he said, was not the first of the ages of reason. He was the last of the magicians, the last of the Babylonians and the Sumerians, the last great mind, which looked out on the visible and intellectual world with the same eyes as those who began to build our intellectual inheritance rather rather less than 10,000 years ago. He continued that Newton believed that these clues left to him by nature, were to be found partly in the evidence of the heavens and in the constitution of elements. And that is what gives the false suggestion of his being an experimental natural philosopher, but also partly in certain papers and traditions handed down by the brethren in an unbroken chain back to the original cryptic revelation in Babylonia. And so this was the legacy left to us by John Maynard Keynes. This legacy where there was a direct line of thought between the way that Isaac Newton conceptualized the world and the way the Sumerians and Babylonians did. But in this was a very biographical or autobiographical take on the history of natural philosophy. One which then would have resonances in the way that other scholars in the 20th century would think as well of the Babylonians. And here we have the famous physicist in 1964 delivering a lecture at Cornell. And this is The Character of Physical Law by Richard Feynman, who we know for his work in quantum mechanics. And this is the way that he described, and hopefully this will be visible here, Babylonian mathematics in that period.
There are two kinds of ways of looking at mathematics, which for the purpose of this lecture, I will call the Babylonian tradition and the Greek tradition. In Babylonian schools in mathematics, the student would learn something by doing a large number of examples until he caught on to the general rule. Also, a large amount of geometry, for example, was known. A lot of properties of circles, theorem of Pythagoras, for example, formulas for the areas of cubes and triangles and everything else. And some degree of argument was available to go from one thing to another. Tables of numerical quantities were available so that you could solve elaborate equations and so on. Everything was prepared for calculating things out. But Euclid discovered that there was a way in which all of the theorems of geometry could be ordered from a set of axioms that were particularly simple. And you're all familiar with that much geometry, I'm sure. But the Babylonian attitude was, if I make my way of talking, what I call Babylonian mathematics, is that you know all these various theorems and many of the connections in between, but you've never really realized that it could all come up from a bunch of axioms.
Here, Feynman is describing what he later calls a Babylonian way of thinking, a Babylonian style of mathematics, where rather than rely on a foundational axiom, you have many points of experimentation, many points of data that can be reconciled with one another without relying on a firm foundation. At the same point, he saw a benefit in describing quantum mechanics in a Babylonian way, which is to say, rather than start with the physical laws that we know from Newtonian physics, we can think of quantum mechanics in the way that the Babylonians thought of their own forms of knowledge in mathematics. That is, rather than relying on theorems, we have all of these different ways of connecting knowledge together without relying on a single foundation. At present, he said, we believe that the laws of physics have to have the local character and also the minimum principle, but we do not really know. If you have a structure that is only partly accurate and something that is going to fail, then you write it with just the right axioms. Maybe only one axiom fails and the rest remain. You need only change one little thing. But if you write it with another set of axioms, they may all collapse because they all lean on that one thing that fails. We cannot tell ahead of time without some intuition which is the best way to write it so that we can find out the new solution, the new situation. We must always keep all the alternative ways of looking at a thing in our heads. So physicists, he says, do Babylonian mathematics and pay but little attention to the precise reasoning from fixed axioms. In short, he characterized his experiments in physics, his thinking in physics, as Babylonian.
Ancient mathematics.
This idea of a Babylonian mode of thought resonated well into the 80s, where at the University of Chicago, philosophers like William Wimsatt were inspired by Feynman's description of physics and argued that the edifice of mathematics itself has become less Euclidean, less based on axioms, and is more Babylonian than commonly thought. In other words, there exists overconnected mathematical structures, structures in which many propositions are at the center of multiple derivations, in which multiple non-hierarchical paths are possible from one proposition to another, in which no special set of propositions is identified as the ground of the whole edifice. This is what was characterized well after Feynman as the Babylonian mode of thought. Mark Stowe would later publish this, which I think is a telling description of what we call a Babylonian mode of thought after Feynman and Keynes. Controversy in the philosophy of social sciences centers in large part around a logical structure of the social sciences. There are two basic approaches, he says. The first, the Cartesian Euclidean approach, is the familiar axiomatic one in which the fundamental principles of science are taken as axioms from which the rest are derived as theorems. Because it comes closest to all the social sciences to attaining this axiomatic ideal, economics has occasionally been considered to be the queen of the social sciences. The second approach is the Babylonian. According to it, there is no single logical chain from axioms to theorems, but there are several parallel, intertwined, and mutually reinforcing sets of chains, such that no particular axiom is logically basic. This embracing of uncertainty in a Babylonian mode would then, between 1985 and the early 2000s, inspire the work of Sheila Dow, who is at Sterling University, an economist there, who would write about post-Keynesian economics, bringing then the historiography of this research full circle. She would describe Babylonian thinking as an open system where the identity of all relevant variables and relationships between them is not known. And in any case, the meaning of variables and their interrelations is subject to change. There is scope for creativity and discrete shifts, she says, as well as for stability. Babylonian thought is neither dualistic nor atomistic. The categories used to account for social life in an evolving environment are not seen as readily falling into duals. Indeed, vagueness of categories is seen as the benefit of adaptability within a changing environment where institutions, understanding, and behavior undergo change. In short, what we see here again is a reflection of postmodernity through a Babylonian lens, an embrace of uncertainty brought into the present and characterized as Babylonians rather than Greek. Knowledge in general is in general held with uncertainty by economic agents and by economists. And this she calls a post-Keynesian method characterized as a Babylonian mode of thought. Even in 2012, we are still finding now in post-Keynesian volumes, in volumes on macroeconomics, articles such as these. Are we still Babylonians? The structure and foundations of mathematics from a Wimsattian perspective, going back to the Chicago philosopher here. Talking again about the embrace of uncertainty in economic systems and mathematical systems. Keynes, Feynman, and Wimsatt are not names that we associate at all with the study of cuneiform cultures, a field known today as Assyriology. Yet all of these figures were entirely convinced of something any Assyriologist today would approve of, and that is that Babylonians are good to think with. But they went, I think, a step further. These scholars who I've mentioned today not only held that we are all Babylonians, but that the Babylonian mode of thought is uniquely capable of dealing with modern and postmodern uncertainty, whether it be economic or mathematical. A short story entitled The Lottery of Babylon by Jorge Luis Borges says it best. Speaking as a Babylonian in the first person voice, the protagonist exclaims, "I have known what the Greeks did not, uncertainty." What is this Babylonian mode of thought? It is, I would say, a byproduct of the scientific imagination in the 20th century, an enactment of what Adam Smith in his History of Astronomy once called wonder. That is a subject's ability to cause an almost maddening curiosity in the researcher, to recall that ballerina Lydia Lopakova's term, the Babylonian madness. But wherein at the same time that subject, in this case the Babylonians, are always kept at a certain distance, because indeed the moment one puts something under a microscope, studies it too closely, the result is inevitably disenchantment. And if Smith's concept of wonder has an antonym, it is certainly this idea of disenchantment, knowing a thing too well. While never shedding their identity as torchbearers, Babylonians and Sumerians in the cradle of civilization became something quite different, perhaps romantic and certainly alien in the hands of economists like Keynes, and later Sheila Dow, or physicists like Richard Feynman, and the philosopher William Wimsatt. A certain distance from cuneiform tablets and philology afforded these figures a philosophical outlook elsewhere unseen or lost in the traditional historiography of these ancient Iraqi cultures. Although Richard Feynman was inspired by Otto Neugebauer, something we can talk about in the Q&A, Feynman's Babylonians represented freedom from Greek mathematics rather than a forerunner to it. Equally, for Borges, a Babylonian knowledge of uncertainty provided for his protagonist a certain realism and modernism absent from those Greek rational characters. For neither Feynman nor Keynes, nor indeed the post-Keynesian economic theorists and philosophers, did the Babylonians fall into a traditional evolutionary narrative. What mattered was not that they were the first to develop a particular category of knowledge, but rather that they, the Babylonians of this scientific imagination, could aid us in thinking differently about contemporary problems and categories. In this way, it was precisely the discontinuity that appealed to these intellectuals. For Keynes, the Babylonians were capable, like Newton, of interfacing magic, science, and wonder. In economic history, Keynes discovered that they were able to develop a stable, long-standing economic structure without need of coinage. Thinking like a Babylonian meant thinking beyond the confines of classicism, beyond the axioms inherited from the Hellenic world. Time, I believe, forces me to end here, but although I am clear, I would say, on where the story of the Babylonian mode of thought begins, I do not know where it should end. And perhaps that is the point here, that the Babylonians and the Sumerians, as reimagined by the figures presented here today, should cause us again to wonder, to catch the anti-Euclidean bug, and to engage in a new mode of thought relevant to our present condition. Thank you for your time, and I will leave my contact info here and take any questions you might have.
Thank you so much. That was fantastic. And I think you were able to bring a lot of questions. Do we have any questions right now? We've got a few. So perhaps I'll get started. Well, I just want to say it's interesting how you make the link between, well, to see the link between modern economics and going so far back in time to look at civilizations that we wouldn't normally connect to those kinds of things. There's always kind of like a progress focus in economics, it feels like. So I guess one of the questions linked to the last part there of this kind of the anti-Euclidean bug. Was this a response to postmodernism, or is this something that just happened in tandem? Is there any link between that and postmodernism and philosophy, for example, in the 20th century?
I think that these things always look for ancient parallels. Any sort of reaction in postmodernism looked for some link to the past, whether it be Greek or something else. In many cases, it looked for non-Western forms of knowledge in order to explain, for example, art, changes in art, and its inspiration there. I think the case for where the Babylonians come in is in direct response to where the Greeks had already established themselves. I think there was a space where the Greeks were already established in some way within the discourse of modernity, very clearly in the way that architecture, in the way that literature, you think of Ulysses, the response of modernity was in some way a criticism directly of Greek, let's say, established theorems, axioms, canons of Greek thought were in conversation, I believe, with modernity. I think post-modernity offered something different altogether, but still an aim to look very closely and deeply at the origins of knowledge. And once it became clear that there was something more original, deeper, longer standing than the Greeks, older and more well known now by the late 20th century. It was much more well known than what Keynes had access to. Then you have figures like Sheila Dow, Richard Feynman, who had access to Otto Neugebauer. And I should explain that Otto Neugebauer is one of the famous Assyriologists who was able to decipher many of, let's see if I can get to that slide. There's a bit of a lag here. He was able to decipher many of the cuneiform mathematical tablets. And so actually, yeah, right here, I have a slide showing where Richard Feynman in the 1980s, in his autobiography, was talking about being in the lecture hall as a student when Otto Neugebauer gave a lecture on the Babylonians, which then inspired him to give his own lecture characterizing his physics as Babylonian. And so I think that you were also, even quantum mechanics, even in postmodern economics, we're looking for ways to connect new ideas to distant ones, distant historical ones. And the Babylonians came at a right time for that. What's compelling to me is that this story is not very well known at all, that these connections haven't been made. And there's many more of these. I cut this down quite a bit.
Thank you so much. Professor Gondek has her hand up.
I think your mic is, yes.
Yes, thank you. That was very interesting. I was just wondering about that idea of there being not knowing any uncertainty in Greek theory when Socrates said, "I know nothing." And also, the idea and the importance of the riddle, whether it was the prophetess at the temple of Apollo, or whatever it was, that you couldn't quite know, what to grasp in those cases. And when the Spartans said, "Who will win the war?" she said, "The best men." And when the Athenians asked, she said, "The best men." And it was always guessing. So I'm wondering how that conclusion, was drawn, that where that observation was made. I know something the Greeks didn't know, you see?
Oh, well, for that particular question, I would absolutely read the short story, The Lottery of Babylon, which goes into, it's a beautiful little story, which will answer directly that question. But I think in historical terms, and I think that's the other part of your question, what would Borges say is different from what we would say as historians. As historians, I think what you're asking is something I would never do, which is essentialize, let's say, what Greeks thought about everything or what they knew about uncertainty. But moreover, I think the type of uncertainty we're talking about here and that I presented was regarding mathematical certainty and the idea that mathematics should begin with a set of axioms. The idea that that it should begin, like Euclid, from a point from which you can derive all kinds of theorems. That's not something that the Babylonians had at their disposal. And when Richard Feynman responded in that way, that the Babylonians weren't Euclidean, he was really responding to Otto Neugebauer's presentation of Babylonian mathematics, much like the first tablet that I showed earlier in the presentation, which doesn't include a theorem or anything like a Pythagorean theorem. It simply includes, let's say, its answers, right? It's a list of Pythagorean triples, but it goes well into the thousands, something that really couldn't be achieved if you, if you have a rudimentary mathematical system. You have to have advanced mathematics, and yet at the same time, this advanced mathematics didn't seem to rely on these axioms, these theorems, like we have the a squared plus b squared equals c squared, that is at the basis of the Pythagorean theorem. Nowhere on that tablet do we find anything like that. And so that was, I think, what motivated that debate. But again, I would say that the quote that I ended the lecture with from Jorge Luis Borges, it's required reading that that you look at the Lottery of Babylon. It's a great story that I don't want to spoil.
Thank you.
You're very welcome.
We have a question from Thomas B. In the chat. Can read it out. That's
Western thought, that one?
Mhm.
Western thought can be considered a radical expression of Euclidean axioms and its reductionism, Occam's razor, but with Babylonian thought completely alien or foreign to the Greeks, did Epicurus develop his principle of multiple explanations of several theories consistent with the observed data, retained them all, based on Babylonian influences? I think in many cases, yes, Thomas, you're right. The Babylonians, another way to say this was that the Greeks knew the Babylonians much better than John Maynard Keynes, for example, knew the Babylonians, which say that they had a closer historical connection to them, and that many of their astronomical principles, the numbers that they used to derive their own astronomical studies were based on Babylonian principles themselves. And so that historical and chronological proximity allowed them to be much closer and much richer, I think, than we give them credit for in 20th century discourse, when this sort of essentialism or this characterization of ancient cultures was alive and well. There are famous books, of course, that came out around the same time. Out of Berkeley, The Greeks and the Irrational, for example, was one of these famous books by Dodds that describes just how irrational, how much of the Greeks we miss by boxing them into these rational and axiomatic categories. So you're entirely right that yes, von der Meerup over at Columbia University is a nice introduction to that. And I would add Francesca Roxburgh's Before Nature is another really good resource for thinking about these topics and the comparison between Greek and Babylonian knowledge. One of these principles, we could say, is also the concept of nature, which is the object of inquiry for the natural philosophers for much of history. No, I'll write it down for you. If you want to read more about how the Babylonians thought about nature, I would look at this one. And I think it makes a good complement to philosophy before the Greeks. So we have a much richer understanding, Thomas, of how these cultures would have interacted, how their systems of knowledge would have interacted and what they knew about each other. Of course, by the late periods in Babylonia, many of these Babylonian scholars also had, in their backyard and amongst their own families, Greeks living in Babylon. As Professor Imeke mentioned, that's where Alexander died. And that's where many of the Greeks remained. Greek scholars would have been well-versed in Babylonian lore and mathematics and other things of that nature.
Any other questions? I think Thomas has another one.
He did. That's him there. Otto Neugebauer, very young Otto Neugebauer. And that is his exact sciences in antiquity. So, good question.
I think I have this very theoretical, and I guess I have a question more so about how that translates into, more concrete things. And I think maybe Keynes might be the best venue for approaching that. I guess my question is, how did this research impact Keynes and his development of his theories, and how he approached his field? Is there any links to that?
Well, in all honesty, it's a nascent field for me. The sort of my research into Keynes's theories of macroeconomics. It's as far as the Babylonians were for Keynes, and so I'm going in the other direction of now looking at some of Keynes's theories and seeing what influence his studies of early coinage and early treatises on money might have had then on his idea that, for example, government should intervene in boosting or stimulating an economy. That's once tempted to think that he saw the influence of a state government or a state-governed economy during the third millennium, or had some conversations with professors in Assyriology during that period that led him to take seriously the longevity and strength, historical strength of government intervention, or something like state intervention in the economy, or the power of loans, for example. But it's too early in that part of the research for me to give you a concrete answer. And I think that the gaps of knowledge, or rather the gaps in the archives, wouldn't really permit me to make that link too clearly. When I was in these archives a couple of years ago, I ran into one of the biographers of John Maynard Keynes, and he was looking at some of the same letters, the love letters and the treatises on money, and he's not come up with how or what became of this sort of failed venture in his research. But I think there's certainly something there to excavate. So might require another trip to the archives. There's another question here from Stanford. Should I move on to?
Yeah, absolutely. We have a few minutes left, so this might be the last question.
No problem. Right, Jennifer Pack-Daly here at Stanford History Department. Your argument that many of these 20th century thinkers saw Babylonian mode of thought discontinuous in some sense with the past is very convincing. That made it all the more interesting to me to see Sheila Dow describing one of the strengths of that mode is taxonomic instability as evidence of a sort of evolutionary strength, adaptability within a changing environment where institutions, understandings, and behavior undergo change. Do you find this kind of connection between an evolutionary perspective and a Babylonian mode in the discourse beyond Dow? Dow is one of the final, let's say the last of these post-Keynesian economists to talk about a Babylonian mode of thought. And so when scholars talk about a Babylonian mode of thought, where they adapt, where these properties are in place, adaptability within a changing environment and these things, they do so, I think, with an eye toward always Dow. Maybe out of fear of sounding loony talking about the Babylonians in a post-Keynesian context, but I think it's something that will probably reemerge And it's certainly something I can reach out to Sheila Dow about. She's emeritus, I believe, at Sterling, but still very much active. So it's, again, like Jeremy's earlier question, another point of further inquiry for me, to see what's happened since Sheila Dow's work on the Babylonian mode of thought. You find this kind of connection between an evolutionary perspective. I would like to hear more about this evolutionary perspective. But I hope I've answered at least some of your question.
All right, well, that was the last question. I don't know if we have a shorter question. We still have a few minutes before we have our cutoff at 1. All right, well, I think we'll close out for today. I want to thank you, Eduardo, for joining us today, and for your fantastic presentation, answering our questions, and for all of our guests for joining us. But I'll leave you with the last word, Eduardo.
Well, it's just it's a thanks for the invite, but also just a thanks for providing the opportunity here to have a chance to bring the Babylonians to light in a completely different context than, you know, the history or philosophy departments that I'm accustomed to. And I think it's an important thing to do for us as a Syriologist, but also as scholars, to take into account this influence of the ancient past. You know, when I first read the Food for Thought lecture series and what it entailed, I knew that this was the right type of lecture to present, and perhaps the best kind of place to present it at. So I thank you for all the very good questions, and I hope that you were able to contact me if you have any more questions. An hour is barely enough to handle all that, but I will leave my contact information there once again. And thank you.
Thank you so much. And thank you everyone for joining us. The recording will be up on the Food for Thought Speaker Series website in the coming week, and we hope to see you all soon.